So, today the topic is curve fitting, Vakra Sandhanamu. It's a very important topic for advanced statistical methods. Suppose let xi comma ya, I is equal to 1 to n, be a given set of n pairs. X is an independent variable, y is dependent variable. The general problem in curve fitting is to find, if possible, an analytical expression of the form of the functional relationship suggested by the given data. To identify the model of the given data, collected data, so the suitable technique is curve fitting. Importance of curve fitting is very useful study of correlation and regression. It enables us to represent the relationship between two variables by simple algebraic expressions. For example, to identify the models, for example, y is equal to ax plus bx, bx square plus cx, like this here. So, we have to use this curve fitting. It may be used to estimate the value of one variable which would correspond to the specified value of other variables. So, very useful technique in theory of estimation and also correlation and regression. That curve fitting is mainly depends upon the Legendre principle of least squares. What is the Legendre principle of least squares? It's very powerful technique in curve fittings and other advanced statistical methods. Minimizing the sum of squares of the deviations of the actual values of y from their estimated values as given by the line of best fit. Y values are collected values. Using this line of best fit, we have to calculate the estimated values and take the differences and square and minimize. So, this is the principle of least squares. Legendre defined this concept. So, using this principle of least squares, so first of all we have to draw the graph. Using the graph, identify the model. The graph may be in the form of line or curve like this here. Suppose the graph may be in the form of a line, straight line. So, in this case we have to fit the model, that is the fitting of a straight line. Let us consider the fitting of a straight line. The model is y equal to a plus bx. So, to a set of n points xi comma yi, I is equal to 1 to n, equation 1 represents a family of straight lines for different values of the arbitrary constants a and b are. These two are estimates. So, we have to estimate this a and b, help of the line 1 here. The problem is determine a and b so that the line 1 is the line of best fit. According to the principle of least squares, so to determine a and b, we derived these normal equations, help of the Legendre principle. The first normal equation is summation y is equal to na plus b summation x is the first normal equation to estimate the a value and b value. Second normal equation, summation xy equal to a plus summation x plus b summation x square. Second normal equation to estimate a and b here. Here we have to estimate two arbitrary constants. For these two arbitrary constants, we need two normal equations. So, here there are several factors are there in equation 1 and 2 here. Equations 2 and 3 are known as normal equations, and estimating a and b. Solve 2 and 3 equations, we get a cap and b cap. These are the estimators of a and b. With the values of a and b, so that the line 1 already is noted in the beginning of this title is a line of the best fit to the given set of points here. So, this is a way of fit the straight line equation. So, next one here. So, first one is the linear model, second one is the non-linear model here. This is called a fitting of a parabola here, but in this case the slope is not constant. In the previous model the slope is constant, but in this way in parabolic concept here, so the slope is not constant. So, after identifying the model, we have to graph of the data it may be in the form of a second degree equation or parabola format. Let us consider the fitting of a parabola. Y is equal to a plus bx square, a plus bx plus cx square. Let xi comma yi, I is equal to 1 to n, set of n points. The equation 1 represents a family of parabola of different values of the arbitrary constants a, b and c. The problem is to determine a, b, c, a, b and c, so that equation 1 is the parabola of best fit here. So, to estimate this, these a, b, c values, we required 3 normal equations. The first normal equation, according to principle of least squares, we derived these normal equations. So, help of this principle of least squares. So, first equation, summation y is equal to na plus b summation x plus c summation x square. First normal equation of the fitting of parabola. Second normal equation, summation xy equal to a plus summation x plus b summation x square plus c summation x cube, second normal equation. So, third one, summation x square into y is equal to a summation x square plus b summation x cube plus c summation x power 4. This is the third normal equations. Now, we have to calculate the summation x square, summation x cube, summation x power 4, summation xy, summation x square into y from the data here. Substitute all these factors in this equation 2, 3, 4 and solve it, we get a, b and c. So, obtain equation 1 is the parabola of the best fit to the given set of points here. So, conversion of the data into linear forms is very important one, crucial one here. So, suppose the graph shows non-linear format. In this case, see here, fitting of exponential curve. The form may be fitting of exponential curve, fitting of power curve here. There are 2 types of exponential curves. One is the y is equal to a into e power bx. Second one is the y equal to a into b power x here. In the power is there is a x here. So, x is called independent variable, y is dependent variable. To estimate y, so we have to substitute the x value, automatically we can estimate the y values here using the either first curve or second curve. Second one here is a power curve, y is equal to ax power b. How convert this? So, non-linear forms into linear forms. So, suitable mathematical function is logarithmic function. Using logarithmic function, convert the above exponential and power curves into the linear formats and apply the principle of least squares method to determine the constants a and b, so that the above curves or the curve of the best fit the set of n points here. So, here the important point here is very careful study of the graph. Graph is very essential. So, which curve is to be fitted, either linear or non-linears. So, in the form of in linear category, exponential power curves here. The graph obtained on plotting the data on an arithmetic or semi-logarithmic scale often provides adequate basis for selecting the type of the curve. If yx is the value of the dependent variable, one particular variable, corresponding to the value of x of the independent variable, x is known, we have to estimate y. So, use different forms here, a straight line form, y is equal to a plus bx. In this a plus bx, b is a slope, a is intercept, here b is constant. So, in the second degree here parabola, so y x equal to a plus bx plus cx square is another format here. We can also use ax square plus bx plus c, both are second degree polynomials. Similarly, here in general, in kth degree polynomial, yx equal to a naught plus a1x, a2 x square plus and so on, ak x power k here. So, this is the familiar formats, curve fitting formats. In next one is exponential curve. So, yx equal to a b power x is a exponential format. So, frequently we have to use this concept a power bx. Second degree curve fitted to the logarithmics here, yx equal to ab whole power x cx square is another advanced, so typical curve fitted logarithmic format. So using higher mathematics, so by using finite difference topics, finite difference concept, we can also identify the models here. Suppose in finite difference delta yx equal to constant, delta yx is a small increment in yx, y of function f of x plus h minus f of x is called some delta f of x here. Similarly, delta yx equal to constant value, use straight line. Delta square yx is constant, use parabola, second degree curve. Delta of log yx is a constant value, use exponential curve. Delta square log yx is a constant, use second degree curve fitted to the logarithms. These are the very useful for to research works and for advanced studies. You have to use this important for 4 formats here, A, B, C, D formats here. So this is the curve fitting. So topic is completed. So next. Correlation. The next topic is correlation. Is very useful for all research works here. It's very important for in life sciences, in financial, economics, in other allied areas here. First of all, before going to the correlation, so we have to know some important topics here. Univariate distribution. What is univariate distribution? The distribution involving only one variable is called univariate distribution. For example, marks in statistics, weight of the particular group of students, height, price of commodities, etc., are called univariate distributions. But in this format, we have only one variable is there here in bivariate distribution. This is another very important one, bivariate distribution. The distribution involving only two variables is called bivariate distribution. Example, price and demand of a commodities, rainfall and yield, etc. are bivariate distributions. Here price and demand of a commodities, rainfall, both are related, may be related, may not be related here. To study the relationship between two variables, so we require bivariate distributions here. So next here is multivariate here. This is advanced topic here. So the distribution involving more than two variables is called multivariate distribution. So at a time here simultaneously we have to study the price of the commodity, what is demand of the commodity in the society and the supply of the commodity here. There are three interlinked here. Suppose supply is less here, so automatically demand is increased, price also increase here. To study this type of relations, we have to take this multivariate concepts here. Rainfall, yield and production, so also multivariates here. So this is the interrelated, so correlated variables here. So now to take the correlation, so here we need at least two variables here. We have to examine the relation between any two variables, between 2 or 3 variables like this. If what is the meaning of correlation? Correlation here is called a sahasambandamu. Telugulo sahasambandamu antaru. So if the change in one variable affects the change in other variables, both variables are said to be correlated. ఒక వేరియబుల్లో వచ్చిన మార్పు వల్ల మరొక వేరియబుల్లో కూడా మార్పు వచ్చినట్లయితే అటువంటి వేరియబుల్లను సహసంబంధ చలరాశులు అంటారు. So simply we can say that interdependency is also called correlation or covariation. So in short term, the tendency of simultaneous variation between two variables. ఒకదాని తర్వాత ఒక వేరియబుల్స్లో సైమల్టేనియస్గా వేరియేషన్స్ అనేవి మనం గమనించినట్లయితే వాటిని కొరిలేషన్ కింద మనం తీసుకోవచ్చు. వాటినే కోవేరియేషన్స్ కూడా అని చెప్పవచ్చు. టు మెజర్ ద ఎక్స్టెంట్, డిగ్రీ, తరగతి. సో వాటి యొక్క టు మెజర్ ద ఎక్స్టెంట్ ఆఫ్ ది రిలేషన్షిప్ బిట్వీన్ two variables or covariation between two variables is the subject matter of correlation analysis. Types of correlation. So, several types are there here. So, these are very important to measure the correlation coefficient between the two variables. First of all, before going to this one, we have to know these concepts here. So, what types of correlation is available here? If the two variables deviate in the same direction, that is increase or decrease in one results in a corresponding increase or decreasing other results here. So, both variables are deviate in the same direction, increase or decrease, we can expect positive correlation. It is also called direct correlation here, that effect is direct here. So, both variables are deviate in the opposite direction, if the increase or decrease in one results in a corresponding decrease or increase in the other variable. Correlation is said to be diverse or negative correlation. It is also called inverse correlation. So, to measure the correlation coefficient between the two variables, first of all we have to identify the nature of the correlation here. So, using nature we can also observe the a degree of the relationship between the two variables also. Next, linear correlation is called a perfect correlation. So, perfect correlation means the perfect correlation of the amount of change in one variable be as a constant ratio to the amount of the change in other variable. For example, x values are 1, 2, 3, 4, 5, y values are 1, so 2, 4, 6, 8, 10 like this here. So, what is the relationship between x and y here? Y is equal to 2x here, but in this here given example, let us consider the following pace of score. Score on x is 10, 12, 11, 19, 13, 16, 15 random scores on x. Scores of y here 12, 14, 13, 21, 15, 18, 17. By keen observation of the y values here, there is some relation between x and y here. What type of relation exists between x and y here? That type of relation is y is equal to x plus 2. Increase by 2 here, we get y values here. There is a linear relationship between x and y, that the correlation coefficient between x and y is perfect. So, correlation between x and y, this is score on x and score on y here. So, next here examples here. Correlation between heights and weights of a group of person, we may expect positive correlation. So, height is increased, automatically weight also increase here. So, income and expenditure, income is increased, expenditure also increased, income decrease, expenditure also decrease here, but in this case we can expect positive correlation between income and expenditure. Similarly, we can also observe the so many examples between positive correlation here. Rainfall and production of rice is a positive correlation, rainfall is increased, automatic production of rice also increase here. So, we can expect positive type of correlation exists between this rainfall and production of rice here. So, next one here, price and demand is very important example for negative correlation. Price is increased, automatically demand also decrease here. When price is decreased, demand also increase here. So, this price and demand depends upon the other factor supply and production here. But here we have to study the strictly two variables. ధరలు వాటి అవసరత వాటి మధ్య ఉన్న correlation మనం నెగటివ్ రుణాత్మక సహసంబంధంగా చెప్పుకోవచ్చు. అవి ఆ రుణాత్మక సంబంధం ఉన్నప్పుడు ఎట్లా వాటిని మనం అనలైజ్ చేయాలి, ఎట్లా వాళ్ళని విశ్లేషించాలి, అవన్నీ కూడా మనం రాబోయే దాంట్లో కూడా మనం నేర్చుకోవచ్చు. అలాగే టెంపరేచర్, డే టెంపరేచర్ పెరిగినప్పుడు, ఉష్ణోగ్రతలు పెరిగినప్పుడు ఉలన్ గార్మెంట్స్ యొక్క సేల్స్ పడిపోతుంటాయి, దాంతోపాటు సాఫ్ట్ డ్రింక్స్ పెరుగుతూ ఉంటాయి. By observing the correlation between day temperature and woolen garments, perfectly there is a negative correlation between these two variables here. Volume and pressure of perfect gas, ilantivi manam different ways ga manam ee examples cheppukovachu. Alage unemployment, power purchasing power of the employee, ilantivi kuda manam correlation kinda manam measurement chesukovachu. So, these are the suitable examples for the positive correlation and negative correlation. Most of the variables in economics and business area shows a relationship here. So, example, price and supply, income and expenditure, advertisement expenditure, sales. So, sales, we have to improve the sales, definitely we have to spend some amount on advertisement expenditure here. Correlation analysis helps the investigator to know the degree and direction on such relation between variables. So, విశ్లేషకులకి ఆ డిగ్రీ మెజర్మెంట్ ఆఫ్ ది కొరిలేషన్లో ఆ డిగ్రీ డైరెక్షన్ పాజిటివా నెగిటివా, హౌ మచ్ కొరిలేటెడ్ బోత్ వేరియబుల్స్, హౌ మచ్ రిలేటెడ్ బోత్ వేరియబుల్స్ అని తెలుసుకోవడానికి ఈ కొరిలేషన్ యొక్క కాన్సెప్ట్ని ఎక్కువగా వివరిగా వాడుతుంటారు. అలాగే నెక్స్ట్ మనం గమనించినట్లయితే నాన్ లీనియర్ కొరిలేషన్ ఉంది. నాన్ లీనియర్ కొరిలేషన్, ఈ నాన్ లీనియర్ కొరిలేషన్ అనేది అడ్వాన్స్ స్టడీస్లో కొరిలేషన్ రేషియో అనే కాన్సెప్ట్లో మనం డిస్కస్ చేసుకోవచ్చు. ఇక్కడ ఒక బ్రీఫ్ ఇంట్రడక్షన్ మీకు నాన్ కొరిలేషన్ గురించి చెప్తాను. ద అమౌంట్ ఆఫ్ చేంజ్ ఇన్ వన్ వేరియబుల్ డస్ నాట్ బియర్ ద కాన్స్టెంట్ రేషియో టు ద అమౌంట్ ఆఫ్ చేంజ్ ఇన్ అదర్ వేరియబుల్. In the previous one, the amount of change in one variable does bear a constant ratio, we get linear correlation, perfect. Here does not bear a constant ratio to the amount of change in one other variable. So mathematically speaking, the correlation is said to be non-linear if the slope of the plotted curve is not constant. So mathematical ga based on the mathematics here, the slope is constant is a straight line, the slope is not constant is a non-linear here. So in this case here, suppose age increased, efficiency also increased at a certain age, that efficiency also fall down here. A suitable example for non-linear correlations here. A graph of variables having such relationship will be a power curve and exponential curves. Data relating to economics and social sciences show the non-linear relationship. So this is the introduction of the correlation analysis here. Now we have to go to the another technique. So in correlation, analysis here, that the first one here, method of studying correlations. So for BA BS students here, to measure the correlation using some techniques here, by using graphical method, by using mathematical techniques here, so by using a rank based method, so by using sign based method here. But in degree syllabus here, we have a graphical method and mathematical method and rank based method here. The first method is method of studying correlation. Carl Pearson, biometrician, define one powerful concept here. He has given a powerful concept as a measure of intensity or degree of linear relationship between two variables. Variables are related. So రెండు చలరాశుల మధ్య సంబంధం ఉంటుంది. ఆ సంబంధం యొక్క తీవ్రతను గణించడానికి ఈ కార్ల్ పియర్సన్ యొక్క సహసంబంధ గుణకం యొక్క ఫార్ములాని మనం వాడుకోవచ్చు. ఇక్కడున్న ఎక్స్ వాల్యూ వై వాల్యూస్ రెండూ కూడా నార్మాలిటీ అనే కండిషన్స్లో ఉంటాయి. సో ఈ కార్ల్ పియర్సన్ ఈ కాన్సెప్ట్ని నార్మల్ బేస్ అనే కాన్సెప్ట్ మీద తీసుకొని ఆయన డెవలప్ చేశారు. ఆ ఫార్ములాని ఇక్కడ డిఫైన్ చేశాం. ఆర్ ఈక్వల్ టు కోవేరియన్స్ ఆఫ్ ఎక్స్ అండ్ వై, కోవేరియన్స్. సో కోవేరియన్స్, కామన్ వేరియేషన్ ఇన్ ఎక్స్ అండ్ వై హియర్. ఎక్స్ some variation x, some variation y, simultaneously we have to observe the covariation dividing by positive square root of variance of x and variance of y. So this is the basic formula here. So we can also modify this formula in different modes here. So for practical purpose, we have to change this formula in different modes. Next here, this Carl Pearson formula is based on the following assumptions. So all students must observe these assumptions here. Based on assumptions, we have to solve any problem related to correlation analysis here. The first assumption, the variables x and y under study are linearly related. This is very important one. When the variables relation is linear, you have to use Carl Pearson formula. So otherwise we may use other techniques here. But second one is very important here. Each of the variable series is being affected by large number of independent contributory causes of such a nature as to produce normal distribution. So actually price and demand, price increase, demand also decrease, income is increase, expenditure also increase. We have to study when how much price is increased, we have to calculate how much increase the expenditure here. Some factors are there here. Some factors are influence the expenditure and also income here. So here we have to study the measure between x and y here. So third point here, the forces operated on each of the variable series are not independent of each other but not related in a causal fashion. So by understanding this third assumption, we have to take this paragraph here. In other words, cause and effect relationship exists between two different forces operating on the items of the two variable series. These forces must be common in both series, x series and y series in common here. If the operating forces are entirely independent of each other and not related in any fashion. For example, so suppose you have to calculate the correlation coefficient between height and marks in mathematics, height of the student and marks in mathematics. So, but actually there is no relation between when a height is increased, so marks has not increased and decreased here. The marks is independent of the height of the student here. So, another example, the series of heights and income of the individuals over a perfect period of time here. So, when measure this correlation by using some formula, that value is not equal to 0, the type of correlation is called spurious correlation, nonsense correlation, chance correlation. So, the students keep in mind here that the series of marriage rate and the rate of agriculture production in a country over a period of time should be 0, because these two variables are independent. So, if any of the above cases, the value of R is given set of data is not 0, then such correlation is termed as chance correlation or spurious correlation or nonsense correlation. So, based on these three assumptions, the Carl Pearson defined the formula to measure the correlation coefficient between variable x and variable y. These two variables are linearly related. This is a very important one here. Next, so concept is properties of correlation coefficient. So, several properties are there. So, are all very important to solve any problem related to correlation analysis here. The first property, so keep in mind, the Pearson correlation coefficient cannot exceed 1 numerically, that is symbolically -1 to +1, both are including. Suppose R equal to +1, the variables having perfect positive correlated, R is equal to -1 perfectly negative correlated here, R equal to 0, there is no correlation. So, second property, correlation coefficient is independent of change of origin and scale, is very important property to solve any problem here. Suppose x is increased by adding some constant value in x series and y series, by subtracting, by dividing, by multiplying any constant value. So, correlation is independent of change of origin and scale. So, this is a very important and powerful property in correlation analysis. Third one, if x and y variables are random variables and a, b, c, d are any numbers provided only that a comma c not equal to 0, then R of ax plus by, R of ax plus b, cy plus d. So, ax plus b is a linear format, cy plus d is another linear format. So, by measuring the correlation coefficient between here, we have to use some technique here. So, here a and a, b, c are arbitrary constants. So, correlation coefficient between ax plus b, cy plus d. So, these two are the straight line formats. What is the correlation coefficient between this one? So, by applying change of origin scale techniques here, AC by mod AC into R of x comma y. Suppose a and c are same signs. Same signs means a is positive, c is positive, a is negative, c is negative. But this value is R of ax plus b comma cy plus d is equal to simply R, because of AC by AC is cancelled here. Suppose a and c are opposite signs here. Suppose a is positive, c is negative, a is negative, c is positive. In this case, that R of ax plus b comma cy plus d is equal to minus R of x comma y here. So, remember one point here, a and c are same signs, b, c do constants. So, no effect on the correlation here, no effect on the sign of the correlation, only a and c are effect of the sign of the correlation here. Both a and c are same signs. So, R of ax plus b, cy plus d is equal to R. So, opposite signs, you should take minus sign here. This is the third property of the correlation. There is another property here. So, two independent variables are uncorrelated, but the converse is not true. Actually, converse may not true here. So, suppose x and y are two independent variables, the R of x comma y is 0. So, converse is not true here, R of x comma y is 0. So, the two variables may not be independent variable. In future, actually may be independent variable. In a degree level, the two variables x and y are independent variables. So, R of x comma y is 0. So, it is very important property. Once again, if x and y are independent variables, then correlation coefficient between x and y is 0, but converse is not 0. Converse is not true means if r of x comma y is 0, correlation coefficient between x and y is 0, that x and y may not be independent, So now go to the property 5. Property 5 is the another important property. So now suppose we have a one linear equation that is called ax plus by plus c, but ax plus by plus c equal to 0. A, b, c are what here? Arbitrary constants. So here c is called intercept here. So quotient of x is a, quotient of y is b here. Now observe the sign of these two here. If both a and b are same signs, r is -1. That is called perfect positive correlation exists between x and y. So a and b are opposite signs here. A and b are opposite signs. In this case, r of x comma y is equal to +1 here. For example, 3x plus 4y plus 5 equal to 0, but r of x comma y is -1. So 4x minus 7y plus 5 equal to 0, r of x comma y is equal to +1. So this is another very important property. So now here, using all these properties, easily we can solve any problem related to correlation analysis here. So next one, another very important oldest technique in correlation analysis, probable error. Probable error is the oldest technique. The calculated or measured correlation is significant or not here. మనం కనుక్కున్న ఆ సహసంబంధ విలువకి సార్థకత ఉంటుందా లేదా, అది ఫర్దర్గా వాడచ్చా వాడకూడదా, ఇవన్నీ తెలుసుకోవాలంటే మనం ప్రాబబుల్ ఎర్రర్ నేర్చుకోవాలి. సో బట్ నవేడేస్ వీ హ్యావ్ టు యూజ్ student t test here by significance of the correlation coefficient, but in oldest technique here, so we have to use probable error. It is usually denoted by P of R, probable error of correlation coefficient, is an oldest measure for testing the reliability of an observed correlation coefficient. Observed means calculated correlation coefficient. X values are there, y values are there, formula here. Using the formula, so we obtain the value of R. Is it significant R here? R is the observed correlation coefficient in a sample of n pairs of observations. The sample is collected from the population. So n pairs of observations, then it's a standard error usually denoted by, so before observing the probable error, we have to calculate the standard error. Krama దోషము అంటారు. ఈ క్రమదోషం అనేది చాలా ఇంపార్టెంట్. ఆ క్రమదోషాన్ని మనం క్యాలిక్యులేట్ చేయాలి. SE of R is equal to 1 minus r square by root n అనే కాన్సెప్ట్ బేస్ చేసుకొని మనం ముందు స్టాండర్డ్ ఎర్రర్ క్యాలిక్యులేట్ చేయాలి. ఫార్ములా ఏంటి? 1 minus r square by root n. ఆ ఫార్ములా యూజ్ R అంటే శాంపుల్ కొరిలేషన్, అబ్టైన్డ్ కొరిలేషన్, n అంటే శాంపుల్ సైజ్. సో using this formula we have to calculate the standard error of correlation. After that here we have defined the probable error of correlation coefficient is given by P of R 0.675, 1 minus r square by root n, 0.675, 6745, 1 minus r square by root n is a formula for measuring the probable error. So using this formula we have to calculate the probable error. Suppose now compare this probable error with correlation coefficient. So whether this R is significant or not here. So R is less than P of R. Correlation coefficient between two variables is already calculated, already used in the calculation of SE of R. So that R value less than P of R. మీరు ఆల్రెడీ ఇంతకుముందు కనుక్కున్న సహసంబంధం యొక్క విలువ R వాల్యూను ప్రాబబుల్ ఎర్రర్తో మనం కంపేర్ చేసుకోవాలి. దాంతో కంపేర్ చేసుకున్నప్పుడు R లెస్ దాన్ P of R. correlation is not at all significant. లెస్ దాన్ అయితే correlation not at all significant. ఎటువంటి సార్థకత లేదు, మీరు కనుక్కున్న విలువకి ఎటువంటి సార్థకత లేదు అనేది ఒక అర్థం వస్తుంది. కాబట్టి R is greater than 6 times of P of R, 6 times of P of R. సో R is definitely significant. ఒకవేళ మీరు కనుక్కున్న సహసంబంధం విలువ P of R కన్నా ఎక్కువ ఉన్నట్లయితే, 6 times of P of R ఎక్కువ ఉన్నట్లయితే అప్పుడు Rకి సిగ్నిఫికెంట్ ఉంది, సార్థకత ఉంది అని చెప్పవచ్చు. బట్ నవేడేస్ no need to take this probable error to measuring the to identify the significance of correlation or not here. Use W.S. Gossett correlation formula in this case. So we have to use the correlation coefficient, test for correlation coefficient అనే కాన్సెప్ట్ యూజ్ చేసి మనం స్మాల్ శాంపుల్ టెస్ట్లో ఈ టెస్ట్ ఫర్ సింగిల్ కొరిలేషన్ కోఎఫిషియంట్ గురించి అక్కడ మనం చేస్తాం. సో దిస్ ఈజ్ ద ఓల్డెస్ట్ టెక్నిక్ హియర్. సో నెక్స్ట్ ర్యాంక్స్ మెథడ్, Spearman's rank correlation coefficient. So is another very important. So actually when the data is normal, both x and y are normal variates, we have to use Carl Pearson. So our measurement variables are quantitative variables, you can apply the Carl Pearson method, but variables are qualitative variables free from distribution. So the distribution is unknown here. In this case Charles Edward Spearman, a British psychologist, developed a formula in 1904 which consists in obtaining the correlation coefficient between the ranks of individuals in two attributes under study. So very important one here. So in many research works we have to use this rank correlation coefficient technique here. The Pearson correlation coefficient between ranks x and y is called rank correlation coefficient between characteristics of A and B for that group of individuals. Suppose the raw data is there here, quantity data is there here, by assigning ranks we have to apply this Spearman's. So without assigning the ranks, directly go to the Carl Pearson method here. So now the Spearman's rank correlation coefficient usually denoted by rho. Rho is a Greek letter here, rho is given by formula rho equal to 1 minus 6 summation di square by n into n square minus 1 for tied ranks here. So ranks are unequal. So here we have to use this concept here for untied ranks. So use the following formula rho equal to 1 minus 6 summation d square plus tx ty n into n square minus 1. But there is small change in correction in formula for actually here. So ranks are untied here. So rho equal to 1 minus 6 summation d square by n into n square minus 1. For untied ranks we have to use the some correction factors tx and ty here. So what is tx and ty? There is a correction factor in x and correction factor in y here. D is the difference between the pairs of ranks. So m is the number of times an item is repeated here. So in the formula tx and ty, so summation mi into mi square minus 1 by 12, ty is equal to summation mj into mj square minus 1 by 12 here. So using these two correction factors in x and y here, so using formula, so rho equal to 1 minus 6 summation d square plus tx plus ty by so n into n square minus 1. This Carl Pearson, so rho r value lie between minus 1 plus 1, the Spearman's so value also lie between minus 1 plus 1, rho equal to plus 1, there is perfect positive rank correlation between two attribute values here. Rho is equal to minus 1, there is a perfect negative so correlation between rank correlation between two attribute values. Rho equal to 0, there is no so rank correlation between so two attribute values here. So here Spearman's is the some assumptions here. Spearman's such measure here free from distribution, since no strict assumptions are made about the form of the population from which the sample observations are drawn. Is very important here. So distribution free method here. So in non-parametric cases here we have to use this Spearman's rank correlation technique here. Spearman's formula is the only formula to be used in finding the correlation coefficient if you are dealing with qualitative characteristics. That is very important. So which are the qualitative characteristics? Honesty, beauty, efficiency, music, so happiness, joyness, sickness, like this here. These are the qualitative characteristics which cannot be measured quantitatively. So measuring the honest, measuring the ranks, happiness, measuring the joyness, sickness, sadness, for all these cases here we have to assign some ranks or grades here. Using that ranks and grades you have to calculate, measure the correlation. For this case you have to Spearman's formula is preferred to Pearson formula here, Carl Pearson formula. Spearman's formula has its limitations also here. Some limitations are there. It is not practicable in the case of bivariate frequency distribution. So correlation table here. So two-way table. For two-way table this is not useful here. For more than, greater than, for n is greater than 30, this formula should not be used unless the ranks are given. Since in the contrary cases the calculations are quite time consuming here. So So, more than 30, so do not use this Spearman's rank correlation formula here. So, next this topic is over. So, next topic. Next topic, regression analysis is another very important concept in degree curriculum. So, it is very important topic, is a basic topic in secondary statistical methods. So, regression. So, what is meaning of regression? Pratiggamanamu antaru. Pratiggamanamu. So, the prices of the commodities or demand or production of the commodities, any commodity is maybe so abnormally increased after some time, so back towards the average production, average sales, average price of the commodities here. But in this case we have to study this one here. Sir Francis Galton study this case, this regression analysis here. Regression means stepping back towards the average. Regression analysis is a mathematical measure of the average relationship between two or more variables in terms of original units of data. Regression analysis is very powerful technique, is a mathematical, purely mathematical technique here. So, mathematical average relationship between two or more variable in terms of original units of data. In regression analysis, there are two types of variables. The variable whose values is influenced or to be predicted is called dependent variable. It is also called regressed or explained variable antaru. So, ఒకటేమో independent variable అయితే మరొకటేమో dependent variable ఉంటుంది. So, independent variable, using independent variable we can also observe the dependent variable behavior here. So, independent variable is also called regressor variable, predictor variable, explanatory variables. Dependent variables also called regressor variable, explained variable or a predicted variable here. So, there are two types of variables here. So, the dependent variable in the regression equation is modeled as a function of the independent variable. So, we have to construct the model, help of the curve fitting, principle of least squares, we develop the model based on the principle of least squares, we have to construct the regression models. So, in the regression equation, so one is the independent variable, other is a dependent variable. So, here the dependent variable in the regression equation is modeled as a function of the independent variable. Corresponding parameters, one is constant, other is error term. Error term is treated as a random variable. It follows normal distribution. So, remember that point here. It represents explained variation in the dependent variable. The parameters are estimated so as to give a best fit. Of the data. Most commonly, the best fit is evaluated by using the least square method, but other criteria have also been used here. So, now types of regression. Linear regression is available, non-linear regression is also available, but in the curriculum strictly we have to study the linear regression model here. Linear regression is a form of the regression analysis in which the relationship between one or more independent variables and other variables called the dependent variable is modeled by a least square function called linear regression equation. So, it is very important one. Linear regression equation is a linear combination of one or more model parameters called regression coefficients here. So, here in detail I will explain here. So, linear regression equation with one independent variable represents a straight line when the predicted value from the regression equation is plotted against the independent variable. This is called a simple linear regression equation, simple linear regression. For non-linear cases here, not form a straight line here, is a parabolic format, exponential format is already explained in the curve fitting chapter. So, non-linear regression is a form of regression analysis in which observational data are modeled by a function which is not non-linear. That is very important. Is a linear, is called a linear regression, is non-linear, is called a non-linear regressions. Combination of the model parameters and depends on one or more independent variables. lines of regression. So, there are two lines of regression. One is the linear line of regression of y on x, other is the line of regression of x on y. Line of regression is the line which gives the best estimates of one variable for any given value of other variable. Suppose some set of data is collected from the classroom here, marks in mathematics, marks in statistics. Is there any relation here? We have to identify the relation and construct the regression line equation. If you know the mathematics marks, we can calculate, we can estimate the statistics marks. If you know the statistics marks, we can estimate the mathematics marks. Help of this linear regression technique. The linear regression of y on x is the line which gives the best estimate for the value of y for any specified value of x. That is very important. For estimating y, use y on x regression line. Don't mix up here. The line of regression of x on y is the line which gives the best estimate for the value of x for any specified value of y. That is here in this case to estimate x, help of the y. So, if y is known, we have to estimate x with the help of the x on y. Don't mix up here. To estimate x here, use x on y line only. So, next here equation of line of regression of y on x. What is the equation here? So, help of the principle of least squares. So, and derived this equation, help of the and also and using some geometrical techniques here, the slope-intercept form here. What is the slope-intercept form? Y minus y1 is equal to m into x minus x1. But in this equation, so y1, x1, y1 are x bar and y bar here. X bar, y bar is the mean of x and mean of y. And what is the slope of the line here? The slope of the line is by on x. It is called regression coefficient y on x. Now, help of the principle of least squares and derived this concept here. Y minus y bar is equal to by on x, x minus x bar. Replace y1, y bar, replace x1, x bar, replace m, y, by on x here. So, help of the slope intercept form, we can also write this equation. So, equation of line of regression x on y is given by. So, similarly, we have to derive this equation, help of the principle of least squares, x minus x bar is equal to bx on y, y minus y bar, but is not a slope intercept form. So, remember this point here, but in this case here the slope is 1 by bxy, x on y here. Slope is not bx on y here, the slope is 1 by bx on y, where by on x is the regression coefficient of y on x, bx on y is the regression coefficient of x on y. Next, regression coefficient of x, y on x, how measure this one? So, help of the mathematical techniques here. So, we have to calculate the regression coefficient of y on x. By on x equal to n into summation xy minus summation x into summation y. The numerator value is n into summation xy minus summation x into summation y by n into summation x square minus summation x whole square. Help of this formula, easily we can calculate this by on x directly from the data here. Suppose if you have a covariance values and variance of values, use the second formula. The regression coefficient of y on x may be defined as like this: summation x minus x bar, y minus y bar, sum of product of deviations taken from respective means dividing by sum of squares of deviations taken from their mean. So, the ratio of this one is called regression coefficient of y on x. Is also called, this may be defined like this: covariance x comma y by variance of x. The covariance x comma y in terms of correlation are sigma y, sigma x into sigma y by sigma x square. By cancellation, finally we get r into sigma y by sigma x. This is the brief explanation of the regression coefficient of y on x. So, next one is similarly, so we have to take regression coefficient of x on y. Similarly, applying the same techniques, the regression coefficient of x on y is r into sigma x by sigma y. So, why took two regression lines? This is very important topic here, is a 5 marks question in all examination point of view. So, why we have to take these two lines here? So, there are two lines here, one is y on x, other is x on y. So, x is in y on x, x is independent variable, y is dependent variable. In x on y, so y is independent variable, x is dependent variable. So, what is the reason to take these two regression lines? Minimizing the sum of squares of errors parallel to y-axis, parallel to y-axis. Y-axis is there here, this is x-axis, sleeping line, standing line, sleeping line is x-axis, standing line is y-axis here. So, the parallel to y-axis, this is a here y-axis, this is parallel to y-axis here. So, generates the y on x line here, generates the y on x lines. Here next one is the line of regression x on y is used to estimate or predict the value of x for a given value of y when x is dependent variable and y is independent variable, minimizing the sum of errors parallel to x-axis here. This is x-axis here, this is x-axis, this is parallel to, so here parallel to x-axis like this here, parallel to x-axis. Y gives the equation of, so regression of line of x on y here. So next one, so properties of regression coefficient. These are very, very important properties. So first property is b y on x is the regression coefficient of y on x. It represents the increment in the value of dependent variable y corresponding to a change in the value of unit change in the value of independent variable. Similarly, in the bx on y, it represents increment in the value of dependent variable x corresponding to a unit change in the value of independent variable. So third one, correlation coefficient is the geometric mean of two regression coefficients. The geometric mean of two numbers. What is the formula? Square root of a into b, but a and b are positive values. Here also a is called b on y, y on x. So b is called b x on y here. So r is equal to plus or minus square root of b y on x into b x on y. The sign of correlation coefficient is the same as that of regression coefficients. If both regression coefficients are positive, correlation is positive. Both are negative, correlation is negative. One is positive, other is negative, correlation does not exist. This is a remember here. So that the sign of the correlation coefficient is the same as that of regression coefficient. Third property is the fundamental property of regression coefficients. Next one of the regression coefficient is greater than 1, other is must be less than 1. Suppose b x on y is greater than 1, b y on x less than 1, b x on y is less than 1. So b y on x is greater than 1, one is greater than 1, other is less than 1. The modulus of arithmetic mean of two regression coefficients not less than the modulus of correlation coefficient. Simply we can say that the arithmetic mean of two regression coefficients is not less than the modulus value of correlation coefficient here. The sixth point is very important point here. Correlation coefficient is independent of change of origin scale, but here regression coefficients are independent of change of origin but not of scale. Because of arithmetic mean is effect of independent of change of origin. So change of origin scale, standard deviation is independent of change of origin but not of scale. So regression coefficients also independent of change of origin but not of scale. Next last, here angle between two regression lines. So here this is the two lines here, this is the angle here, we can measure the angle may be so acute angle and obtuse angle here. So if r is equal to 0, these two lines are here like this here, the two lines becomes perpendicular to each other here. This is one line here, this other line here, these two lines are perpendicular. The angle between these two lines here 90 degrees here. So the tan theta value is, so here is infinity, the theta is pi by 2. So using this formula we can observe the behavior of the lines here. Here suppose here these two lines like this coincide at a point here, these two lines cannot be parallel. Why? Because these two lines passing through x bar and y bar here, this is x bar and y bar. Here these two lines cannot be parallel and coincide at a point here. The point is here x bar and y bar. So in this case here the angle here is 0 or pi degrees here. So tan theta value is 0, theta value is 0 or pi degrees. The two variables perfectly positive or negative correlated, the two lines regression coincide here. So standard error of estimate x is given by, so Sx sigma x into 1 minus r square 1 by whole power 1 by 2 క్రమదోషము. So to estimate this క్రమదోషాన్ని అంచనా వేయడానికి xలో ఒక ఫార్ములా yలో ఒక ఫార్ములా ఇక్కడ చెప్పడం జరిగింది. Sx equal to sigma x into 1 minus r square whole power 1 by 2, Sy is equal to sigma y 1 minus r square whole power 1 by 2. So, this is the 3 topics, regression quotients, regression analysis, properties. So, importance of the properties of the regression quotients all are explained here. These are very useful topics.